compound measure. A lot of this should be very familiar with us. We've seen things like this in physics or science. We've also used it in maths as well in the past. So compound measure is whenever we've got three things that are related together. And the ones that are commonly seen within maths are going to be speed, density, and pressure. So we should know the formula speed equals distance over time. You've probably had like a triangle for that, where you've got speed at the bottom, distance at the top, and time on the bottom as well. And what we can do is if we cover one of those up, so if we cover speed up, it tells us that distance over time is how you work that out. If you cover distance as well, the speed and the time are left and they're being multiplied together, so distance is speed times time. Or similarly, time is found by doing distance divided by speed. The same would be true for density, where density is mass divided by volume. So density is mass over volume. And again, we can cover up the volume, and that would be that density or volume is mass divided by density, and covering up the mass would equal density times volume. And then again, we can do the same with pressure. So pressure then is going to be force divided by area. And then if we cover up the area would equal force divided by pressure, and force would equal pressure multiplied by area. So we hopefully are familiar with those anyway. The common units for speed are meters per second, kilometers per hour, miles per hour, and even in the units they tell you how to work out the formula. So in meters per second, the slash, another way to think about that is meters divided by seconds, or meters over second. Meters is a representation of distance, and seconds is for time. So we've got distance divided by time. So we can, from the units, figure out what it is. Similarly with density, we've got grams per cubic centimetre. So that's grams divided by cubic centimetres, which is mass divided by volume. So the units let us know what's going on as well. The key thing about these equations as well is that the units must be consistent. So if our units that we're looking at are kilograms per cubic metres, that means all our measurements should be in kilograms and cubic metres. If we're in kilometres per hour, again it's kilometres and hours. If it's newtons per square metres, then we need to look at force being in newtons and area being in square metres. So if it was in square centimetres or something that wasn't in units, we'd have to convert those. So example 34. A car travels at 32 kilometres per hour for 12 minutes. How far does it travel? So far is a distance. So what we're going to have to do is we're going to figure out what the distance is. And we know that speed equals distance over time. So then distance is going to be speed times time. Now the thing as well we said a minute ago was about units being consistent, and what we can see, we've got kilometres per hour and we've got minutes. So what we need to do is we need to change the minutes into hours. So 12 minutes, that's going to be 12/60ths of an hour, which is 0.2 hours. So now, whenever we're doing distance is speed times time, we can do 32 multiplied by 0.2, and we get 6.4 kilometres. Example 35, a mass of 605 grams has a density of 8 grams per cubic centimetre. So looking at the units there, we've got grams and grams per cubic centimetre, so they match, so we don't need to worry too much about that. If it's in the shape of a cube, find its length. So what we can do with this is we've got mass, density. The other measure then is volume. And we know that density is mass over volume. So then volume is going to be mass divided by density. So that's 605 divided by 8, which is 75.625. And that's cubic centimetres. What we know is that it's in the shape of a cube, this mass, whatever it happens to be. And a cube, you'll remember the volume of that, all the sides are the same, so the volume is going to be length cubed. So L times L times L. So what we know is the length cubed is equal to 75.625. To work out the length, we need to do the cube root of 75.625, and we get an answer of 4.23 centimetres to 2 decimal places. Example 36. Now, to convert units from metres per second to kilometres per hour, what we need to do is we need to think about what the units actually mean. So 20 metres per second means that every second you'll travel 20 metres. So if you travel 20 metres in a second, how far will you travel in a minute? Well, to work that out, you'll multiply by 60 and we'll get 1,200 metres in a minute. Then we need to think, well, if there's 1,200 metres every minute, we can figure out how far it will travel in an hour. And again, we'll multiply by 60 because there's 60 minutes in an hour, and we get 72,000 metres in an hour. But 72,000 metres isn't really very good. It's not very useful to us. There's a more useful measure for that, and that's changing into kilometres. And to change from metres into kilometres, we divide by 1,000. So we get 72 kilometres per hour. Now, you can, if we like learning things, just rote learning, to get from metres per second into kilometres per hour, you can multiply by 3.6. But I like how you build it up from metres in a second to how far you would travel in a minute to how far you travel in an hour, and then changing that down into something more meaningful into kilometres. Similarly then, if we're changing 90 kilometres per hour into metres per second, well, 90 kilometres per hour, that is 90,000 metres in an hour. So we know that there's 1,000 metres in a kilometre, so that's how that is. Now, to get from hours into minutes, you're going to travel a shorter time in a minute than you are in an hour. So we're going to divide by 60. So 90,000 divided by 60 is 1,500 metres in a minute. So then to change that into metres per second, again, you'll travel a shorter distance in 1 second than you will in a minute. So we've got to divide by 60 and we get 25 metres per second. Again, if you like to learn things off by rote, but again, you can forget which way it's going to be. To get from 90 to 25, you could divide by 3.6. But again, building it up from 90 kilometres per hour to the metres in an hour, and then dividing down to get how far you travel in a minute and to how far you travel in a second is a much more logical and simple way to think about it.